matrix. Let's say you have a matrix A. A matrix A, which is equal to A, B, C, D. Then A inverse will be given by 1 over the determinant of A. We already looked at, in the last section, we already looked at how to get the determinant, multiplied by interchanging this matrix, so such that this AD will change their position. So this will be D, this will be A, and then these values here will be negated so that I have minus B there and minus C there. So basically, that's how we go about getting the inverse of a matrix. So let's take up an example. Let's say we have our matrix A equals to 3 minus 1 minus 4, 7. And then we're being asked to get A inverse. So how do we go about getting A inverse? So first of all, we'll start by getting the determinant. So A inverse is equal to 1 over the determinant of A multiplied by interchanging the values here. We will have 7 here, 3 here, and negating these sides will give positive 1 and positive 4. So what's the determinant of this? The determinant of A will be equal to multiplying the main diagonal, that is 21, minus multiplying this, that is 4. So what does that give? That will give us 17. So what's the answer for the inverse? 1 over the determinant, that is 1 over 17 multiplied by 7143. And multiplying this by each term here, we will have 7 over 17, 1 over 17, 4 over 17, 3 over 17. So that's basically how we go about getting the inverse of a 2 by 2 matrix, guys. Okay, so what of a 3 by 3 matrix? So how do we go about getting the determinant of a 3 by 3 matrix, guys? So given an arbitrary 3 by 3 matrix, the determinant, sorry, not the determinant, but the inverse. Actually, let's start by getting the determinant, because in order for us to get the inverse, then it's important that we know how to get the determinant. So let's say you have a matrix like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Or let me just pick on this values here. 1, 0, 1. Now, how do we go about getting the determinant? Let's call this matrix A. So what is determinant of A? This is how we go about getting the A determinant. So we will decide to, okay, Crescent. If you have no audio reception, then it's on your end. So are you able to try and join using your computer audio or using using your phone audio? I want to hear from the rest of you. Alex, you're here. Are you able to hear me? Alex. Okay, Dika, are you able to hear me? Adika, can you hear me? Okay, Alex, what about you? I can see you've unmuted. Can you hear me? Adika, can you hear me?
Yes, I'm getting you.
Okay, sawa. Because there's someone who's complaining they can't hear me. So chances, Christy, Crescent, chances are very high that it can be on your end. Crescent, are you able to hear me now?
Yeah, it's already help. I think he can hear you.
Okay, sawa sawa basi. Aya, so determinant of a 3 by 3 matrix. So we can be able to evaluate the determinant across any row here, and I will choose to evaluate it across row 1. So taking the coefficient of the first row, I will get the determinant of the matrix that is left. So getting the determinant is like just writing the 2 lines. When I delete the row and column in which one lies in. Now I want you guys to see this. Deleting the row and column in which one lies in, I remain with this right here as my small matrix, which is 5, 6, 0, 1. Taking the coefficient of this point right here. There's so much noise from someone. Okay, so guys, taking the coefficient of this height right here, this position always comes with a negative. So I will take -2, then delete the row and column. Delete the row and column in which this 2 lies in. So it lies in row 1 and then column 2. So the small matrix remaining is 4, 6, 1, 1. 4, 6, 1, 1. Then finally take this coefficient plus 3 and then delete the row and column in which it lies in. Then the small matrix left will be 4, 5, 1, 0. So 4, 5, 1, 0. So evaluating this gives me 1 into, these 2 lines imply that you get the determinant. Omai Robinson, it could be on your side probably because the rest can hear me. So getting the determinant of this is 5, 1 multiplied by 0. So that will be 5 minus 0 minus 2. Get the determinant of this. So this is 4 times 1 minus 6. So that is 4 minus 6 plus 3, 0 minus 5. So that is 0 minus 5. So finally, the determinant is 5 minus, this gives me minus 2 here. So this will be plus 4. And then this will give me minus 5. So that will be minus 15. So our answer right here will be 9 minus 15. Are we together, guys? So basically this gives us minus 6 as the determinant. So when you're evaluating the determinant of a 3 by 3 matrix, that's basically how you go about it. I want to open another section so that we can do another example. Okay, let's take up example number 2. So let's say you're told to evaluate 3, 4, minus 1, 2, 0, 7, 1 minus 3, 2. When it's written as those 2 lines, it basically means the determinant. So this value will be given, taking 3, delete the row and column in which 3 lies in, and then find the determinant of that small matrix that is left, which is this one. So that will be 0, 7 minus 3, 2. This middle position here comes with negative. So -4, deleting the row and column in which -4 lies in, row, column, I will remain with 2, 7, 1, 2. So 2, 7, 1, 2. Then finally taking the last position in the row, -1, deleting the row and column in which it lies in, I will remain with 2, 0, 1 minus 3. 2, 0, 1 minus 3. So evaluating this, we get this here. If we get the determinant, this is 0, minus 21. So that is 0 plus 21 minus 4. This will give 4 minus 7. And then minus 1. This will give minus 6 minus 0. So that will give 321 minus 4 minus 7 will give minus 3, and then minus 1 minus 6. So you can evaluate that and you should be able to get your answer. You should be able to get your answer when you evaluate that. So guys, I hope that is clear on how to get the determinant of a 3 by 3 matrix. I would like for us to now look at the inverse of a 3 by 3 matrix. I would like for us to look at the inverse of a 3 by 3 matrix. I want to open another section, so I hope you guys have already finished writing this part here. Okay, so the inverse of a 3 by 3 matrix. Okay, so the inverse of a 3 by 3 matrix, if we are looking for A inverse is given by adjoint A Okay, A inverse is given by adjoint A over the determinant of A. A inverse is given by adjoint A over, this can also be written as 1 over the determinant of A multiplied by adjoint of A. Now, we already know how to get the determinant of a 3 by 3 matrix. That's what we have been looking at all the time. So basically, what is remaining is how to get the adjoint. Now, how do we go about getting the adjoint of a 3 by 3 matrix? Now, to get the adjoint of a 3 by 3 matrix, we first of all start by getting its minors. So, we first of all start by getting the cofactors of the element, then transposing it. Now, cofactors of the elements, this is how we go about getting the cofactors of the element. Now, it's best done like using examples. We're going to get the, let's say we have a matrix like this, 3, 4, minus 1, 2, 0, 7, 1, minus 3, minus 2. Now, in order for us to get the adjoint, we will first of all start by getting the cofactors. Now, this is what happens when you're getting the cofactors. Adjoint, so let me write here, adjoint, we will get it by cofactors. So cofactors, and then we transpose the cofactors. So how do we get the cofactors, guys? Now, if we want to get the cofactors of this particular matrix, let's say we take position 3, we come and delete the row and column in which 3 lies in, and then we get the determinant of that 3 there. Like this is what we will have. Deleting row and column of 3, we will remain with 0, 7, minus 3, minus 2. We do the same for all the positions in this matrix. So let's say, for example, we want to get the cofactors of this position 2. We come delete the row and column in which 2 lies in, and then we will remain with 4 minus 1 minus 3 minus 2. We get the determinant of that. Then for 1 here, deleting the row and column in which it lies in, we remain with the small matrix 4 minus 1, 0, 7. We do the same for all the other elements. So let's go. We are here at 4. Deleting the row and column in which 4 lies in, we remain with 2, 7, 1 minus 2. So 2, 7, 1 minus 2. Deleting the row and column in which minus 1 lies in, we remain with 2, 0, 1 minus 3. So 2, 0, 1 minus 3. Deleting the row and column in which 0 lies in, so 0 is here and here, we remain with 3 minus 1, 1 minus 2. So 3 minus 1, 1 minus 2. Okay, here at this position 7, deleting the row and column, we remain with 3, 4, 1 minus 3. So 3, 4, 1 minus 3. Okay, deleting the row and column in which 3 lies in. Deleting the row and column in which 3 lies in, we remain with 3 minus 1, 2, 7. So 3 minus 1, 2, 7. And finally, for this position, deleting the row and column, we remain with 3, 4, 2, 0. 3, 4, 2, 0. So guys, evaluating these values here is what will give us the cofactors. Evaluating the values here is what will give us the cofactors. So for example, if you want to evaluate this, this is 0. So this will give us, this is 0 minus 21. So that will be positive 21. And here we have minus 4 minus 7. So that will give us minus 11. And here we have minus 6 minus 0. So that will give us, this is minus 11. So let me write it so that it's visible. This is minus 11, and this will give us minus 6. Here we have minus 8. Minus 8 minus 3. So that will give us minus 11 as well. Then here we have minus 6 plus 1. So that will give us minus 5. Here we have minus 9 minus 4. That will give us minus 13. Here we have 28 minus 0. So that will give us 28. And here we have 21 plus 2, so that will give us 23. And then this is 0 minus 8, so that will give us minus 8. Minus 8. Okay, I want to write the brackets. So that's what we get there. Now, the next thing, as you can see, if we want to get the adjoint, we are supposed to get the cofactors and then transpose. So I want to show you guys how to transpose a matrix. So transpose. Given, let's say a matrix A is equal to 2, 1, 4, 2. Now A transpose will be given by, so transposing basically means interchanging rows and column. Okay, interchanging rows and columns. So as you can see here, 2, 1 is our first row, so it will become our first column when we are transposing. And then 4, 2 is our second row, it will become our second column when we are transposing. Let's take up another example. We have A is equal to 1, 4, 1, 1, 3, 6. So what is A transpose? A transpose is equal to, so interchanging the rows and columns, we will have This is our first row. It will now become our first column. So we will have 1, 4. This is our second row. It will now become our second column. We will have 1, 1. And this is our third row. It will now become our third column. We will have 3, 6, guys. So that's basically how we go about transposing. Now let's take up an example. Let's say I give you A is equal to 1, 7, 8. What is A transpose? Anyone, what is A transpose? Guys, what is A transpose? Anyone? Okay, so A transpose will be taking row 1. Row 1 will be column 1. So our row 1 will be column 1. Row 2 will be column 2. Row 3 will be column 3. Okay, the reason as to why I was showing you how to transpose is because we wanted to look at, so where was it? I think it was in section 10. We are looking at how to get the determinant, and I have said it is given by adjoint, and adjoint is given by cofactors transpose. Now we were going to get the cofactors. We started by getting the minors. Now what you need to note is that cofactors is given by signed minor. So these are the values of our minor here. So in order for us to get the cofactor, we sign them. What does signing them mean? We multiply them by their corresponding signs. Now, if you have a 3 by 3 matrix, so I would like for us to note this, so I'll write it somewhere. It was 21 minus 11 minus 6. Minus 11 minus 5. (28, 23 minus 8). Okay. 28, 23 minus 8. I hope I've copied it correctly. So like this is the matrix minor. This is our minor. So what is assigned minor? We will multiply this by the corresponding position of each element. Now for a 3 by 3 matrix, these are the signs. Plus, minus, plus, minus, plus. Like they go as they're changing from plus to minus, plus, like that. Plus, minus, plus. So signed minor, what will be our signed minor? And our signed minor is also what we call the cofactor. So our signed minor will be, we multiply each position by the corresponding sign. So this will give us 21, multiplying this by negative, that will give us 11. We have like 10 minutes to go, so I hope I'll be done by then. Multiplying this by this will give us minus 6. Multiplying this by the sign, that will give us 11. This by the sign, that will give us minus 5. Multiplying this by the sign, that will give us 13. Multiplying this by the sign, that will be 28. This by the sign, that will be minus 23. And then this by the sign, that will be minus 8. So this is our cofactor. But how do we get the adjoint? Because remember, we wanted to get A inverse, and we said A inverse is equal to 1 over the determinant of A multiplied by adjoint of A. And we said that adjoint of A is given by cofactor transpose. So if we transpose the cofactor, we get this. So this is the cofactor. So what is the transpose of this? So I will have 1 over the determinant. What did we get to be our determinant? So I have to go back, I can't remember. Our determinant was, did you look for the determinant really? Okay, so we didn't get the determinant, guys. Here is the value, but I hope you guys can remember how we are supposed to get the determinant. So getting the determinant, we were supposed to take 21, then delete the row and column in which 21 lies in. Then we evaluate these values here. So minus 5 minus 13, 23 minus 8. Then this position comes with a negative, so now it will be plus 11. Delete the column in which it lies in, so that we remain with minus 11 minus 13, 28 minus 8, then minus 6. Delete the row and column in which it lies in, then we remain with minus 11 minus 5, 28, 23. So this is what, if you evaluate this, this will give us the determinant of this matrix. Now, finishing up, after we get the determinants, so after we get the determinants, our answer is supposed to be equal to 1 over the determinant, 1 over the determinant, whatever value it's going to be, 1 over the determinant multiplied by adjoint. And what is our adjoint? Our adjoint will be our cofactor transpose. Now this is our cofactor. So transposing it, we interchange rows and columns. So this was our row 1, 21, 11 minus 6. So that will be 21, 11 minus 6. And then this is our row 2. So we will have 11 minus 5, 13. This is our row 3. It will now become our column 3, 28 minus 23 minus 8. So if you evaluate this here and then come and divide it with whatever is in here, that will give you the answer. That will give you the answer of the inverse. Okay, guys. So that's it for the inverse. Maybe we can take up another example, though we really have only 6 minutes left. So I don't know if we will be able to finish in 6 minutes time. Let's see. Let's say you're given a matrix A is equal to, so matrix A is equal to, let's say you have values like 1, 2, 1, 0, 2, 0, 1, 1, 1. And then you're being told to get A inverse. So as we've said, A inverse is equal to 1 over the determinant of A multiplied by the adjoint of A. And how do we get adjoint of A? Adjoint of A is given by cofactor of A, and then you transpose it. But how do we get cofactor? Cofactor is equal to sine minor. So those are things we need to remember. Cofactor is equal to sine minor. So first of all, can we start by getting the determinant of A? Come and take 1, delete the row and column in which 1 lies in. We will remain with this small matrix, 2, 0, 1, 1. Take this, this comes with minus 2. Delete the row and column in which it lies in. Then we remain with 0, 0, 1, 0. So 0, 0, 1, 1, sorry. If you delete this, 0, 0, 1, 1. Then plus 1, delete the row and column in this lies in. So we will have 0, 2, 1, 1. So evaluating that, what do we get? This gives me 2 minus 0, so that will be 2 minus. This gives me 0 minus 0, so that will be 0. Then finally plus 0 minus 2, so that will give me minus 2. So actually, this is not a very good example because the determinant here will be equal to 0. So this is a singular matrix. So whatever we will get on this other side as the adjoint will not really matter because at the end of the day, this is already 0. So if you multiply with this, we are not going to get the answer. But let's just say we wanted to get the minors just in order for me to show you guys. How do we get minors and sign them? Now, in order for us to get minors, for each position, we will delete and remain with a small matrix form. Like for position 1, delete the row and column in which 1 lies in. So to get the minors, delete the row and column in which 1 lies in. I will remain with the matrix 2, 0, 1, 1. Delete the row and column in which 2 lies in. I will remain with the matrix 0, 0, 1, 1. Delete the row and column in which 1 lies in. I will remain with the matrix 0, 2, 1, 1. Delete the row and column in which this 0 lies in. I will remain with the matrix 2, 1, 1, 1. 2, 1, 1, 1. Delete the row and column in which this 2 lies in. I will remain with the matrix 1, 1, 1, 1. So 1, 1, 1, 1. Delete the row and column in which this 0 lies in. I will remain with 1, 2, 1, 1. 1, 2, 1, 1. And finally, for the last row, delete the row and column in which this 1 lies in. I will remain with 2, 1, 2, 0. So 2, 1, 2, 0. Delete the row and column in which this 1 lies in. I will remain with 1, 1, 0, 0. So 1, 1, 0, 0. And finally, delete the row and column in which this 1 lies in. I will remain with 1, 2, 0, 2. 1, 2, 0, 2. So this matrix here, if you evaluate, this is what is called minors. Like evaluating these lines is just getting 2 minus 0, 0 minus 1. You're getting the determinants. And sign, when you multiply it with the signs. So I told you the corresponding signs of a 3 by 3 matrix is plus, minus, plus, minus, plus, minus, plus, minus, plus. So each term you will be multiplying with its corresponding signs, and whatever you're going to get here is what we call a signed minor or a cofactor. So in order for you to get the adjoint, then you will have to transpose the cofactor, and I've already shown you guys how exactly you're supposed to go about transposing the cofactor. Okay, guys, so that's it for today's session.